Hello students. Now we are starting with chapter number 5, that is the states of matter. I hope all of you are well and you are studying well. So up in this chapter we will study about especially about liquid and gaseous state. Solid state we will discuss in 12th standard. As you know, there are total 5 states of matter, but 3 states are important, that is solid, liquid and gas. Now chemical properties of substance do not change with change of its physical state, but the rate of chemical reaction do depend upon the physical state. Suppose we are reacting solid silver nitrate and solid sodium chloride, then maybe the reaction will be slow. But if we dissolve them in water and the reaction is carried out, the reaction will be faster. So we can say that as physical state change, the rate of reaction will be increases. But it do not affect the chemical properties of the substance. Suppose we take water. If it is in solid state, then to its chemical formula is H2O. If it is in liquid state, then also it is H2O. And if it is in vapor state, then also it is H2O. So chemical composition or chemical property do not depend on physical state, but the rate of reaction depends on physical state. Many times in calculations while dealing with data of experiments, we require knowledge of states of matter. Okay, how much gaseous products are obtained, calculate that. What is the volume of the gas obtained? So in states of matter is important in dealing with the calculations. And so it becomes necessary to know what is the physical state of matter. Now to know the physical state, it is necessary to understand the nature of intermolecular forces, molecular interactions, and the effect of thermal energy on motion of particles, because a balance between them only determines the state of substance. So physical state of a substance depends on intermolecular attraction force basically and an effect of thermal energy. So first we will discuss about intermolecular forces that are present between molecules or atoms, and then we will discuss about thermal energy. After studying both the factors, we will see how these two factors decide the physical state of matter. Now intermolecular attractions. What is intermolecular attraction? In last chapter in chemical bonding, we had completed why two atoms join together to form a molecule, and we studied about covalent bond, ionic bond. Covalent bond and ionic bond exist between atoms or ions, but right now we are studying about intermolecular attraction, means the attraction between two molecules, या फिर attraction between two atoms that are not able to form molecules. That type of attraction we have to discuss. Intermolecular forces of attraction and repulsion play a very important role in deciding the physical state of matter. And this intermolecular attraction do not include, as I told you, about ionic bond or covalent bond. Ionic bond and covalent bond are interatomic attraction, while intermolecular attraction consists of dispersion forces, London forces. London forces, depends on the name of scientist. फिर dipole forces of attraction, dipole induced dipole forces of attraction. These are intermolecular attraction forces that we have to study in this chapter. We'll study them one by one. So there are 3 intermolecular attraction: London force या dispersion force, उसके बाद dipole forces, and third is dipole induced dipole forces. All comes under van der Waals forces of attraction. Van der Waals is the name of scientist. Now first is dispersion force or London forces of attraction. Students बहुत ध्यान से सुनना, समझना इनको, because this type of force of attraction play very important role in deciding melting points and boiling points. When you will study organic or any other molecules or compounds, then they will tell you to explain why boiling point of this compound is more than that. At that time we have to use this dispersion force, dipole-dipole attraction and all. So listen carefully. It's very important in near chemistry future. Clear? सबसे पहली बात, this type of force of attraction existing between two non-polar molecules. Yeah, the atoms which are not capable of forming the bond. So atom and non-polar molecules are electrically symmetrical and they have no dipole moment because their electronic charges cloud is symmetrically distributed. Means this type of force of attraction existing between two molecules which are non-polar, and we know that non-polar molecules do not have any dipole moment. Their electronic cloud is symmetrically distributed, but a dipole may develop momentarily even in such atom or molecule, and this can be understood by taking an example. Suppose we have two atoms A and B. They are in close vicinity to each other. See, I'll show you in a diagram. These are two atoms A and B, and they are close enough to each other so that attraction force can be developed. Right now their electron cloud is symmetrically distributed because they are in a spherical shape. See, likha hai, symmetrical distribution of electronic charge cloud. Right now there is no attraction. Both have symmetrically distributed electronic charge cloud. These are two atoms A and B. Suppose we have two atoms and they are close to each other. What will happen? It may so happen that for a moment electronic charge distribution in one of the atom become unsymmetrical. Matlab charge cloud is more on one side than the other. See, I'll show you in diagram. This is atom A and its electronic cloud is now unsymmetrical. Initially it was symmetrical. See, spherically symmetrical. But for a moment of time, there is, distribution of the charges. Yahan pe plus likha hai, it means that at that particular end, there is deficiency of electrons. While at this end, there is excess of electrons. For a moment of time, this will happen. Clear? Electrons are continuously moving in an atom. So for a moment, it so happened that all the electrons gathered at one place. So at that particular place, suppose this end, because of electron, it get negatively charged. And other end, because there is no electron, so it will become positively charged. So for a moment, a dipole is formed in one atom. This dipole is called instantaneous dipole. Dipole का मतलब होता है जिसमें दो charges होते हैं, एक तरफ plus, एक तरफ minus. उसको हम dipole बोलते हैं. So in first atom A, for a moment, a dipole is formed and that is called instantaneous. Instantaneous means fraction of second के लिए बनेगा ये. Okay, so this type of dipole is called instantaneous dipole. Now what will happen when this electron cloud या A atoms का electron cloud का symmetry disturb हो जाए, dissymmetry हो जाए, ये spherical से elliptical type हो गया, मतलब इसमें dipole create हो गया, then what will happen? ये जो dipole बना है instantaneous dipole, what it will do? It will form, it will create, it will form a dipole in second atom B. Because of A, B also become distorted. Symmetry of B also become disturbed. It will also become unsymmetrical. Initially, it was also symmetrically distributed electron cloud, but આનું પણ શું થાય છે electron cloud? Dissymmetrical થઈ જાય છે આના લીધે. અને ઈ જે બને dipole એમાં બે આટમમાં એને કહેવાય induced dipole. So first instantaneous dipole is formed and after some time induced dipole is created in another atom A. Attraction between these two dipole, that is instantaneous dipole and induced dipole, is known as London forces of attraction या फिर dispersion forces of attraction. As I told you, for a very short time this type of force of attraction developed. So this is very weak force of attraction. આખી દુનિયામાં weakest force of attraction છે તો આ છે. અમુક distance ઉપર જ લાગે. તમે બે મોલેક્યુલ ને દૂર લઈ જાઓ તો આ attraction feel જ નહીં થાય, એવું છે. આ universal છે. દરેક બે મોલેક્યુલ બે એટમ વચ્ચે આ attraction તો હોય જ. આપણી તમારી મારી વચ્ચે attraction છે. तो का फील नहीं थતું because we are far away from one another. बहुत close, मतलब atoms के बीच में distance I think 4 angstrom जैसा होगा तब तो ये feel होता है. मतलब इतना weak force of attraction है. Clear? So important points. this force of attraction existing between two non-polar molecules, and it develops instantaneous dipole in one atom and induced dipole in another atom. Attraction between these two dipoles is known as London force or dispersion forces of attraction. ऐसा भी हो सकता है A में इस साइड इलेक्ट्रॉन्स है और इस साइड इलेक्ट्रॉन की डेफिशिएंसी, उल्टा भी हो सकता है. At this end there may be electronic cloud and at this end electrons will be missing. So whatever be the dipole, there is attraction between them for a moment. This type of attraction force is known as dispersion या London forces of attraction. Clear? This all explained over here. One important point for the maths students, कि these forces are always attractive. Interaction energy is inversely proportional to the sixth power of the distance between two interacting particles. ये JEE में पूछा हुआ क्वेश्चन है बच्चों, कि दो मॉलिक्यूल्स या दो एटम्स के बीच में कितना डिस्टेंस होता है या डिस्टेंस और इंटरैक्शन एनर्जी में क्या रिलेशन होता है. तो इंटरैक्शन एनर्जी इज डायरेक्टली प्रोपोर्शनल टू 1/r⁶. Okay, r is the distance between two particles. These forces are important only at a short distance. I told you 500 picometer. એનાથી દૂર જો બે એટમ્સ હશે અથવા બે મોલેક્યુલ્સ હશે તો આ force of attraction feel ही नहीं થાય. So what I mean to say, this is weakest force of attraction existing between all type of molecules, whether covalent molecules or ionic molecules or atoms of inert gases, इनके बीच में भी attraction force होता है. कोई पूछे कि दो हीलियम एटम के बीच में कौन सा attraction है, तो dispersion force of attraction. दो नियॉन एटम के बीच में कौन सा attraction है, तो dispersion force of attraction. ये dispersion force of attraction जो पोलराइजेबिलिटी होती है उसकी मैग्नीट्यूड पे डिपेंड करता है. मतलब जो इलेक्ट्रॉन क्लाउड है वो कितना डिसिमेट्रिकल होता है उसको पोलराइजेबिलिटी बोलते हैं. કેટલું પોઝિટિવ અને નેગેટિવ ચાર્જ ડેવલપ થાય એના મેગ્નીટ્યુડ ઉપર આ ફોર્સ ઓફ એટ્રેક્શન ડિપેન્ડ કરે. જેટલું વધારે પોલરાઇઝેબિલિટી હશે એટલું વધારે સ્ટ્રોંગર આ હશે, પણ એટલું બધું કઈ સ્ટ્રોંગ છે નહીં. આ સૌથી વીકેસ્ટ ફોર્સ ઓફ એટ્રેક્શન છે. ઓકે, નાઉ second type of force of attraction is dipole forces of attraction. As name suggests, there is interaction or attraction between two dipoles. Now what is dipole? Which has two pole. Two pole मतलब एक ज molecule માં एक negative pole હોય અને એક positive pole હોય, તો શું કહેવાય? Dipole. Now first point is this type of force of attraction existing between two polar molecules. Clear? Like HCl, HBr, HI, which has a polar bond. Their net dipole moment is not zero. Such molecules are called polar molecules. सबसे पहले ये जो force of attraction है ये polar molecules के बीच में लगता है. Act between polar molecule possessing permanent dipole. आगे जो पढ़ा उसमें कैसा था, थोड़े टाइम के लिए डाइपोल क्रिएट होता है, पहले से डाइपोल नहीं होता. इसमें तो मॉलिक्यूल्स में पहले से डाइपोल है, मतलब दे हैव परमानेंट डाइपोल. एंड्स ऑफ द डाइपोल possess पार्शियल चार्जेस. पार्शियल को डेल्टा से डिनोट करते हैं. पार्शियल चार्जेस आर ऑलवेज लेस देन द कूलम्बिक चार्ज. जैसे अगर H और Cl के बीच में बॉन्ड है, we know Cl is more electronegative, so it get partial negative charge. So that partial negative charge is less than 1.6 into 10 to the power minus 19 coulomb. It's not exactly 1.6 into 10 to the power minus 19 coulomb. The polar molecule interact with neighboring molecule. मतलब two polar molecule attract each other, the dipoles attract each other, and the force of attraction is known as dipole attraction force. Now, this interaction is stronger than the London force. जो आपने प्रीवियस वन पढ़ा वो थोड़ा वीकर है, मैंने बोला वो तो सबसे वीकर फोर्स ऑफ अट्रैक्शन है, डिस्पर्शन. तो डाइपोल उससे ज्यादा थोड़ा स्ट्रॉन्गर है. कहाँ काम लेंगे हम इसको? जैसे पूछेगा कि HCl और हीलियम है हमारे पास, लिक्विड हीलियम है और लिक्विड HCl है ना, which is having higher boiling point. So obvious HCl is having higher boiling point because in HCl molecule there is dipole attraction which is stronger. And between two helium atoms, there is a London force of attraction, which is weaker. Okay. So boiling point depend on intermolecular attraction. As intermolecular attraction is less, more molecules will be converted into vapors, and the boiling point will be less. So it is this what we call dipole-dipole forces are stronger but weaker than ion-ion interaction. Suppose one positive and one negative ion interact, जैसे ionic bond होता है, obvious है उससे weak है, लेकिन London forces of attraction से stronger होता है, because only partial charges are involved. जबकि ions में क्या होता है, exact charges होते हैं. जैसे मैंने Na+ बनाया, Cl- बनाया, तो Cl के ऊपर माइनस चार्ज है, -1, उस वक्त वैल्यू होगा 1.6 × 10⁻19 कूलम. लेकिन अगर HCl के बीच में जब Cl पार्शियल नेगेटिव चार्ज डेवलप करता है, तब चार्जेस कितना होता है, लेस देन 1.6 × 10⁻19 कूलम. So as partial charges are involved, this force is weaker than ion-ion interaction. The attractive force decrease with increase of the distance between the dipole. दो डाइपोल के बीच का डिस्टेंस अगर कम होगा तो अट्रैक्शन ज्यादा होगा, और अगर डिस्टेंस ज्यादा होगा तो अट्रैक्शन कम. ठीक है. It is inversely proportional to that. Obvious है. If two molecules are far apart from each other, attraction will be less. And if two molecules are near to each other, the attraction will be more. Its interaction energy for stationary polar molecule. सॉलिड जैसे, सॉलिड में दो मॉलिक्यूल स्टेशनरी होते हैं, मूव नहीं करते हैं, उस वक्त ये होता है प्रोपोर्शनल टू 1/r³. लेकिन अगर दो रोटेटिंग पोलर मॉलिक्यूल्स है जो लिक्विड में होंगे, गैसियस में होंगे, तो ये डिपेंड करता है 1/r²⁶, प्रोपोर्शनल टू 1/r²⁶, where r is distance between the polar molecules. भले डाइपोल डाइपोल इंटरेक्शन है पोलर मॉलिक्यूल्स में, लेकिन जैसे मैंने आपको बोला, लंडन फोर्स और डिस्पर्शन फोर्सेस ऑफ अट्रैक्शन तो यूनिवर्सल है, वो तो सारे मॉलिक्यूल्स में प्रेजेंट होते हैं, तो वो तो इसमें भी प्रेजेंट होंगे. तो डाइपोल डाइपोल इंटरेक्शन के साथ पोलर मॉलिक्यूल्स कैन इंटरैक्ट बाय लंडन फोर्सेस आल्सो. सो दे हैव क्यूमुलेटिव इफेक्ट, यानी टोटल इंटरमॉलिक्यूलर फोर्सेस इन द पोलर मॉलिक्यूल इंक्रीजेस. लंडन फोर्सेस हैव ओनली लंडन फोर्सेस ऑफ अट्रैक्शन, बट डाइपोल डाइपोल अट्रैक्शन के साथ लंडन फोर्सेस ऑफ अट्रैक्शन भी होता है, इसलिए दोनों का क्यूमुलेटिव इफेक्ट अपन को देखने मिलेगा. दैट्स व्हाई इट इज स्ट्रॉन्गर कंपेयर टू डिस्पर्शन या लंडन फोर्सेस ऑफ अट्रैक्शन. सी, दिस इज HCl molecule. There is covalent bond between H and Cl, single covalent bond. As Cl is more electronegative, it gets partial negative charge. H is less electronegative, so it get partial positive charge. मतलब shared electron move towards chlorine, so there is more charge density towards chlorine. Okay, see, Cl gets partial negative, partial એટલે delta बनाते हैं, and H has partial positive charge. This is one molecule. It has permanent dipole. This is another molecule. This is also having one dipole. So attraction between negative pole of one molecule, positive pole of one molecule is called dipole-dipole attraction, and stronger than London forces of attraction because it has permanent dipole. अगर जो बने तो हमें permanent dipole ना हो, एक instantaneous dipole हो, and बीजू induced dipole हो, हमें तो permanent dipole चाहिए. At least this type of force of attraction is stronger compared to London forces of attraction. Clear? In next video, we will talk about third type of force of attraction, and that is induced dipole, that is existing between one polar and one non-polar molecule. Clear? Study well. As I told you, this force of attractions are very, very important. So just remember them. There is not it's not necessary that it will ask in your exams, explain London force or explain this force. No, but we have to apply this in 12th standard. And that's why concept should be clear. What is dipole-dipole attraction and what is London forces of attraction. Clear, students? Next video, we will talk about third type of intermolecular attraction force. Bye, beta.